directory, we could put a whole file system into this assets directory. So let's try to put something into assets directory. I have a video file here, and I go to my application 5, app source main assets, and put this big file. It's a huge file. It is a file of size, a video file of size 178 megabyte, so it's quite big, and this one is part of my application. Now that's if the application is compiled, the application will be a little bit bigger than this compressed file, so it should be about 180 megabytes then. So it will be copied, this assets folder, the complete structure will be copied into my application. I could create some new folder as well, could say, okay, this is a video folder, and put this file into this folder to say, okay, there's a complete file structure down here, and we want to see how to access this file structure now. So in our text view, I want to find some information about the content of my assets here, and if we want to access the assets, we need a object. It's called asset manager, and it's part of our resources object. So we have a resources object. It's coming from originally from get resources, but in Kotlin we just access the getter method with a name here, resources, and it will be translated to a get resources call. If we want to access the resources, we directly come to one thing, it's get assets, and it delivers us a assets manager, and with this assets manager we can do some interesting things. We could access the assets like we want to list those assets once. We can try to list a root folder, and then we can say, okay, this creates a list, and I want to have each here, or I want to fold this list somehow together. If I want to fold it, I have an initial value, a string. I just want to concat everything, so I fold it with a string, the initial string, and I have an operation which is appending this string to another string. I start with a empty string, and a operation followed is how to combine those strings, and it must return a string as well. So I should return a string, or just have it like this. And why? Let's see. We have only 2 parts, so and we get a string and the R, and this should be like this. It is a accumulator string, and the item, which is a string, and this will be then oh, it does not return anything. It just changes the accumulator, I think. Doesn't return anything. So the accumulator gets this one, or we return both together like this. Could be folding array string case extension function. What? Okay, it should be like this. Okay, and what is now the problem here? We have this one, and we don't return, just write it. Let's see. That's correct. So two parameters. The first parameter is the accumulator. It's initially empty, and we get it back again. We append the string to this, and we could do it with commas. So we could say, okay, return a new string, which is comma it, and this should be in the text view. We could save it. Oh, moment. We could save it and then put it into the text view. And this is a Kotlin style program now, which is checking the resources with this path, and let's see what is under this path. So we were building it, now we install it. And after installation we should see it's still applying changes because this file is very big. It's 178 megabytes. Then it will be deployed and run. So we now see some information that is inside the root folder of our application path. So our application gets extracted, and in this extracted path we have on the top of our file system the manifest file, we have meta information, we have assets folder, we have classes dex, which is all our classes together in one big binary file. We have a Kotlin folder, we have resources folder, and we have some special informations additionally to our resources. So this is similar to our project folder. If you look into this project folder main, you see assets, you see here is Java, in the other one is classes dex and Kotlin, and then we have resources and manifest. So this is the thing we find in our project folder, in our application folder on the phone if it is extracted. This is the root folder for our application. But we aren't interested in the root folder, we are interested in the assets folder. And to access the assets folder, I just skip this information. I leave the path empty, so I give a empty string into the path. If I restart my application, I try to restart it. I don't know if it is working, because no, it is working at the moment, because the file is very big. So we have just images, video, and WebKit. It's part of our assets. In the assets folder is something images, WebKit, and video. So the video is what we were creating. The other things are already there, but we did not deliver them. They were created from this IntelliJ and the Gradle. They created some additional things because our resources, which are delivered automatically, access some assets as well. So there are some other assets in our package too. And we could look into this images path to see, okay, what is in this? What is in the side, the image assets? Maybe I just take images, and it is top level of the assets folder. At the moment we can't install it because the file system is full. I just uninstall and reinstall the application, and then we can go on viewing the images folder, and we will see that those drawable objects here go into the assets folder too. But only those PNG files, I think. The XML files go into a other compressed file. Is it running now? Yes, we have Android logo mask, Android logo shine, and clock font PNG. So 3 files in the images, and they are not part of this resources. Those are other images which are part of our program, not from the resources, but they were created in this assets folder. So it's sometimes really interesting to have a look into the stuff we get. So, but we created a folder called video, and if we access the video folder, we should see our video file. So I try it once again, apply the changes and run the program, and let's see how to view our file. So here's our file. We see now this is the video file we were using for our lecture, and if we want to run this, if we want to see this video, we could use not a text view, but maybe there's somehow a video view, and there will be a video view. I give it a ID, and maybe it's video view. Invalid ID. So why is invalid? So because maybe should be normally. Oh, good. I call it video. So no problem to call this video. If I want to access this video file now in the video view, just use video and put the path into video, but we can't access the assets in our video file. We are not able to pass the assets folder information to our video path. To create a path in the file system readable for the video view, we should open this assets file and put it on the file system. So, and now we have to have a look onto our file system. What now? Why it is yellow here? Access the file system, and therefore we look into our slides. And here we have some information for data and file storage. So the file storage is a little bit how to say, it is departed into some parts. We have a internal part which is application private, and it is in our application private file system on the device. So it is called the internal data storage. Then we have a part, it's the external data storage, and everything which goes into the external data storage can be shared among applications. And the third part is a shared part, and this shared part is application private data stored as a key value pair in XML files. So these are shared preferences, so they're called, and it's a preferences file like you know it from Java already. So there are XML files which hold key value pairs of any data type, and you can write them into this XML file or read it from the XML file, and we can use those information maybe for storing preferences. So store some settings, reread some settings if you open up your application again, and this is a easy to use approach. We don't have to deal with directly with file system operations. We just use a object and say open up this settings file and access it with primitive data and parsable or yes, serializable objects to write them into a XML file and read them from this. And the third, this was the third approach. The next one is using databases, and if you use databases in Android, you should use the SQLite-driven databases, because there is SQLite installed on every Linux Android system, so we can access SQLite formatted text files. It's similar to those XML key value pairs, but those are simple text files which hold text and binary data together, and it's not the fastest, but it's a very common thing to use because it doesn't need so much runtime like a SQL server. It is just a SQLite program which accesses some files in a SQLite fashion. So we could use SQL to access those files, and the files represent tables in a database, and we have columns, and we have data sets inside those tables, and we can access it. We can join them and so on. We have a complete SQL working system, database access system, and this is very interesting for us to do some more complex, some more interesting programs which go over shared preferences and so on. And the last one is a content provider. If we want to grant other applications access to our private information, maybe our SQLite database, which is privately for us, or only accessible for our application, we could grant it to others if we provide some content. So we create a content provider, and other applications have then access to our database over this content provider interface. So we will go forward and see today internal, external storage, maybe shared preferences, and next week I think we have time to do a little more things with databases, but today we already start with list views and with adapter views. So a list view is a adapter view, so we need a adapter for this. And then we have lots of interesting things done which are already also usable in your attestation programs. Okay, we want to go first into this internal storage. So at the one hand we have a assets file. The assets file is not accessible directly for maybe our video view, but we can copy this file into the local file storage in our private internal file storage, and after we copied this file there, we are able to access it. So how to copy a file into file storage? At first we open the desired file, and our desired file is in the video path called there, we see it here, called there MP4 2020 1127 and so on. So we just have to know how this file is called. Then we can open this file. To do this, I log the text with my log tag on in the logging, the Android log file. So I just create a log tag. We can do it as we did before, statically. Say we have a log tag and it's called main activity. Okay, this is a string which could be 0, so we should use the Elvis operator to produce some text. Sorry, this text was empty. Okay, now it is running. I hope so. Changes were not applied. Renaming a resource requires an application restart, so we resources video ID, so this is very informative. If we change anything in our resources which produces a new identifier, then the R class, the class R, has to be recompiled, and the IDs which were created before aren't you can't be sure that the old IDs you had before are correct to access the compiled resources. That's why if you change something and create a new resource ID, so make a new layout file, or change a value, make a new string here, or make a new part of a layout file, so the video view with a video ID. Every time I do this, create a new ID or delete a older ID, I have to recompile the complete project, and our IntelliJ is aware of this and knows it. In earlier versions, when I used NetBeans to program Android stuff, this NetBeans program was not aware of this mistake, and if you weren't aware by yourself, you could run into trouble. So now we have a video view here, but it doesn't know the size. I just want to see which is the name of our file, and this is here the name. I can copy it now and put it into my program and open this file. I open this file, and we have to look into the video folder. So video, this is the file. We open it and get a input stream. This is a input stream. Next we need a output stream to the file system. This is a file output stream, and the file output stream needs a path 2. The path will be simply this file name, but we need a resource path inside the Linux file system. So at first we have to give the Linux file system a path where we are sure that we are writable, that we can write, and that's a get files directory, or just files dir. It is the get files directory, and this is a object, and if we say give me the absolute path of this one, I can say absolute path. This is the absolute file system path, which points to our private file system, application private file system for the internals. This is the files directory, and I want to append to this path my file. Now I have a output which writes to my files directory. This is a fast access. We can go over the environment too. There is a object called environment, and we can access the environment with directory. These are the external ones here, and we can have methods like get data directory, and this is our private one, and we have external storage states information. We will do something if we go to the external one. We go over the environment, but if we want to use the internal ones, we don't have to go over the environment. We can go directly over this files directory object here, and say give me the absolute path, which is a mapping into the Linux kernel file system structure that says, okay, I have the root and the subfolder, and this somehow is the folder where my application is living, and under this we have a files path where we can write, we have write access. And this can be used for a simple file output stream. You know those stream classes from Java 2. Now we are able to copy the content of this file here into this file there. So how to copy a file in Android? Yes, we read this file from the input. To read it from the input, I need some of the read methods. So we have read, and we can read maybe a byte array here. Therefore, I need a byte array. So first write a byte array. Maybe data is a byte array in Kotlin of size 2024 bytes at a time. It is 1 megabyte. We could make it a little bit bigger. We could say, okay, 4 megabytes. So now we have an array which is 4 megabytes in size. Then we read this data and we get information how much bytes we could read, we can read. This is our count, and then we write it to the output. Again, and we have to repeat this. So why is it right? Wait, output should be right. Byte array, offset and length. So we have byte arrays data, offset is 0, length is count. This is what we do. Normally we get back 4096, and then we append from 0 to 4096 bytes. Okay, we repeat this. That's why this should be a variable. Should maybe start with 0, and then we do a reading. Count is coming from this, and if this count is smaller than 0 or is equal to -1, we should stop it and do the rest while true, maybe. So since we get data, we have a positive count, and in the last turn the count will be -1, and if we get -1 we break this loop. Afterwards we could close. If we are fine, we close our file streams, and this file is now copied. So we could make a method which copies this file in the next step and say, okay, copy this file from this path to this path, or from this stream to this stream, if we have those two streams here. And after we have copied the file, we can access the video and say set video path, put down now our files path, which is the destination. And if we want to play the video, we just say start. So this step should be done only once, because we do not need to copy it every time. We only have to copy it if it is not in our files directory. So we could try to access this file and ask if it exists. And if this does not exist, we have to copy it before we can go on. Okay, so we copy this file only once, and this one we will do every time access this file, and this one here can go into a copy method. This open method call is especially only possible with the resources of with the assets manager, and that's why we should access it here, and the output stream 2, and then copy from input to output stream. Let's make a small copy method which uses this part of code. So just write copy and give into input output, and then we could have a method copy, which is a function using a input which is a file or a input stream, and a output which is a output stream, and returns nothing, so gives back the unit type. And does our copy. Okay, so now our program is better to read. This one here should go into some text, which is the video file. And then we do not have to access this thing here. Like this, okay. And once again here. Now it is simply better. I rebuild my program. And try to restart it. Let's see if there's enough memory to install it on this emulator. So there's actually not enough memory, but I can uninstall this program, release the memory, and restart it. Okay, so now the player is running and the video is running. So you see the video here, it's in a horizontal layout. We have on the left side our text view, on the right side the video view, and this video is playing at the moment. So I have the audio, desktop audio. I hear myself now here. I don't have a controller, so you could write a controller, but this video is now running, and we created it from our assets folder and accessed the assets folder. If you have seen, we can have directory access, we can have files access, and the files access is like a stream. We only have this streaming access like a normal file system. So the assets directory can be accessed like a normal file system over this assets manager. This is I think the message. But if we want to use it in other program parts, like a video view, we have to at first extract this file from the assets folder into a local path, which can be used from this video component, which can be accessed from this video component, like this video path. So on the other hand, we can put the video file in a raw resources folder is a alternative, and in this raw resources folder the file will be indexed. So we have a resources access r.raw.video file maybe, and then we can just set this as a resource, not as a file system path, but we could use resource access here too, like a URI. So from our resources part we can create URIs, and those video object is able to open the raw resources. So in our case, where we want to use our video in the graphical user interface in a video view, it would be preferably better to put this video not into the assets folder but into the raw resources folder, because we want to produce it as output for the UI. But if we have information which is not put out to the user interface, which is just private for us, or we want to share it with other programs, then we should have it in our assets folder and extract them to the file system to share it then with other programs. So if a big huge program is installed and afterwards it wants to share files, it extracts those files, and you know, if I extract this file, it is twice on my phone. So now you should be aware that this technique, having things in assets and extract them to maybe the external or your internal files path, doubles the space amount needed for your application. So be careful when using this. You should always be aware what happens if you do this. We have access to this like a file system. We can access every file we put here into the assets folder, but not for the UI. We can only use them internally or as a stream. So if we have something that accepts a stream, we could put it as a stream. So if this video accepts a stream, but it does not accept a stream, I think, set input stream, somehow it has a video URI and no stream. But if anything accepts a stream, it is best to use the assets folder, because accessing assets is able to be accessed via streams, and resources are not accessed like streams. They are can as well be accessed like streams. So everything can be accessed like a stream. Okay. So now I want to stop this. I just click it away. Okay. This was the first part. The files there, and now let's have maybe some more interesting look into this internal files there. And if we have a nice application which uses a list view and a adapter, we can switch between the internal files, the external files, just have a small file system browser which browses over all those files. Could be the resource assets at the end of the day too. Good. Okay, I take this out. If you have any questions, please feel free to ask, because I delete this code here. Now we don't need it anymore. We want to start over with a little more interesting example and using list views. So I delete these assets again. Okay, let's have a look into the stream, because maybe we have some watchers in the stream too. Good. For list views, we go into the layout and I eliminate everything here and just want to say, okay, we want to have a list view in our Android layout file, and this list view is a simple view. Where do I have my list view example? Here, and you can see this list view like this. Should get an ID. Like list view. Okay, now we have a simple list view, and to use list view we need a adapter, and for this adapter we should create another layout. This list view produces a list of items, and therefore we should create a new layout resources file, which is the information of the list view item. There are already, in part of Android, there are already such layout files available. We could use them from the Android resources. Maybe we find out which Android resources could be used for that. But we can create a own one. Could be list item XML like this, and this list item XML is just a linear layout with a text view. So we could use this one again and say, okay, we just have a linear layout with a simple text view inside. So, and nothing more has to be done. At the moment, nothing more has to be done. We have two files now. This one is the layout file which is produced from our activity. Our activity shows a linear layout with a list view, and the second file is used for the adapter. The adapter then produces list items which are created like this. They are also laid out linearly, and the content of this item is a simple text. Okay, so next we go into our main activity and say we have a list view, so we need to create a adapter for our list view. And yeah, to create a adapter we need some text, or we could append some information to the adapter and it is then produced. The first thing is we import our Android synthetic. We have our Android synthetic imported. Okay, this is fine. And then I need a adapter. This could be a array adapter, and the type of this array adapter should be simply string. To create a array adapter, it needs some parameters here. We need a context. This is the main activity itself. It is the it has a reference, or it is a context, because it extends the activity class, and the activity class extends the context. So this first parameter is the context, and I should use value And the second parameter is then a layout file. We have it in our layout, and here we can access the list item. And the third is the ID, which is used for the string. At the moment we don't have a ID for the string, so we could give it a Android ID, which is maybe item text. Android ID item text, and now we access the item text over this one. There should go the value of this adapter. And the next step is we go into the list and set the adapter. Oh, it is called list view. The adapter is adapter. This value should be we should be able to access this value later on too, but at the moment we just want to put some data into this adapter with the add method, and I can put strings in here. Simply add some string. This could be hello list view, and let's see if this already works. Just build it, try to see if all my resources are correct, if the IDs are correctly set. Is it already built? I think yes. And I try to restart the application. Build finished. And we have hello list view here, so the list is working. This is my first item, and the next item could be then item. So you have now a simple list view with a list adapter, with the array adapter in this case here, and for databases we use a cursor adapter, but the simplest approach is using a array adapter, and we just put data, which are strings here, into this adapter, and this adapter produces string outputs which can be shown there. Okay, see, right, fine. Now we want to create it from the file system. We want to read some file system here. So I go into files directory and want to have a list. So I want to read out this files directory object here. So I take this filesdir and give me a list of files inside this filesdir files directory like this, and this is a array of files which is returned here. And now I can traverse this array and see what is part of my file system. And while I traverse it, I just want to access the file names and produce the file names as value from here. So I say, okay, for each of those things, I want to put them into my adapter, and I access it like this. Now this adapter shows the name of the file. Okay, really cool stuff to do this in Kotlin. So let's see if there's anything on the file system. The file system is empty here. So there's nothing in the file system. Unsafe use of a nullable receiver, so we could use this one too. Okay, this is better. But it's still empty, there's nothing inside our files there. So we could try to have a look into the environment storage. So if we want to access the environment path, we could go to the environment. First I do this entry here. This is empty, and then we have environment, and in this environment we have a root directory. This is the root directory of our file system. We could add it to the adapter 2 to see what is in there. So the root file system part is /system. This is the root we get if we say give me the root directory's absolute path, and we could have a data directory as well in the environment. There is get data directory, and this has a absolute path 2. Now we access, or we have a look at the data directory. Where is the data stored? The data is stored in /data, and the root directory is /system. What else do we have? We could have a download cache directory. It's also part of the environment. Get downloaded cache directories, absolute path, put it into the adapter 2. And it's called data cache. When things are downloaded over any internet connection, this will be stored in a subfolder of data in the cache folder. And if you have something downloaded which is cached there, you can copy it somewhere else and afterwards delete it from the cache. So it's a normal approach if you do downloads to do this over a cache file. Oh, I think there were some information in the chat. I did not look to the chat. Okay. Okay. Good. And the other chat is empty too. Okay. So some minutes left. We could try to access the external storage. If you know, the Android system comes normally with a external storage, and the external storage is only accessible if it is mounted, because it's maybe a removable device. So the internal storage is fixed, the external storage is eventually removable, and if I want to access the external storage, I should at first test if the external memory card is mounted and accessible. So just access or try to check if this equals this environment media mounted. So we have media bed removal, media checking, ejected, media mounted is the state. Is our desired state. We want to check if this is the same. So if environment storage media is mounted, then we have access to our external storage, and now we can check the external storage parts of our file system, which is get external storage directory, but it is deprecated here. Okay, I don't want to tell you deprecated things, so let's try to see what is the new kind of accessing the external storage. Android external storage directory. Here is environment, external storage, and there should be some more information why this is deprecated. To improve privacy is deprecated when app targets build version. The path returned from this method is no longer directly accessible. Apps can continue to access content stored in shared external storage by migrating to alternatives such as context get external files directory or media store or intent action open document. So we could access it over context, get external storage, get external files directory should be there. The context is this. So this is get external files directory is part of our context, the same as this here. Like get files there, we have get external files directory, and we give a path. This is the root path of the external files there, and this can be used to access it. So it is this because this is the activity and this is as well the context. That's why I can leave it away, and we just access the external files there like this way. It's the same as we would access it over the environment, but it's similar. It's the context or the environment is similar to use here in this way. So I can use these external files there, and I want to have the absolute path, and then I just put it to the adapter, this absolute path, and maybe a string version, and this should be safe. Can I take it away? Yes, it is already a string. So let's see what happens. But the media should be checked because external storage may be unmounted. So we have a storage emulated. You see this emulated here from the as number 0. It's part of this storage. This is the external storage. This is internal. This is external, and it is somewhere in Android data. And then this is here my software name. So it's the package name here, and this is called files. This is the external files directory here in this way, and we have a external public directory. Get external, not files there. It is external public. It's called external storage public directory. Normally external files there. We have external files there already, and there's only one. Yes, it's only one for the future. We have no other thing. It's only this one again. So, and this is as well able to access without the environment. It's just get external storage state normally. No, it's environment, so it is similar like this. Okay. Okay, so why don't we have access to the public files directories? This is not so nice. Get external state, okay, but the context access as the alternative is with the string. Oh, we have it with a string. Okay. We have get external files directory with a type, and the type could be, and I should use it from the context, should be somehow directory. No, and normally environment has this directory, and we could say directory downloads as absolute path Let's see if this works. So, okay, we have this download part here. This is the external files directory with where downloads go. We have a external directory where we have documents, movies, music, pictures, notifications, ringtones, podcasts, and so on. We can access so maybe the DSIM directory here, where we have photos, and it is here DSIM. And you know those files, those directories already. If you mount the Android system to a PC, you have access to the SD card, which is the storage emulated, and this is the folders which are accessible in this emulated storage on the SD card. We have access to the downloads folder, the DSIM folder. We have access to podcasts, ringtones, and movies, and so on. Not every folder is present on every phone, but if we access this folder, it will be created. So if we are the first one who writes into this folder should be created too. But if you mount your SD card, you know not always have those folders all available, but normally you have downloads DSIM available. Okay, this is the first approach. It is enough for the first one. For the first time, we want to access it here. If we click on it, we want to open this and go into this folder and want to see what's inside this folder. We just want to browse. Yeah, we want to browse. We want to make it interactive. That's what we do after our pause. Now we make a 15 minutes break, and 11:35 we start again, or 11:32, 33. So we start again and go on creating our system storage browser, and just want to click on every folder, and if this folder is delivered on our application via intent, we just go recursively into the file system, and then we have some interesting things done, which is very helpful for your exam too, I think. Okay, so see you in about 15 minutes.
Thank you, Professor.
Thank you.